All right, hello, good morning, everyone. It is Professor Grenfell once again with the Math 12 lecture. Today we're going to be discussing Chapter 11, Section 2 on other chi-squared tests. The first of which is the chi-squared independence test. And let's see, start broadcast in 3, 2, 1. All right, let's see if this works. Okay, I guess it's on. So let's go ahead and open up my screen to example 11-5 for the chi-squared independence test. This is a test to see if two variables are related to one another or whether they are independent of one another. And so example 11-5 is where we're going to start. In this example, a researcher wishes to see if there is a relationship between the hospital and the number of patient infections, the number and type of patient infections. And so here's the data from a random sample of 3 hospitals and the number of infections of a specific type for one certain year. And here are the data. So hospital A has 41 surgical site infections, 27 pneumonia infections, 51 bloodstream infections, and so on and so forth. So all of the data are listed there in what we call a contingency table. We're going to use that to perform our calculations. But it is a hypothesis test, not unlike any other hypothesis tests that we do. So we're going to go through the 5 steps of hypothesis testing. Step 1 is to state the hypotheses. So we have the null hypothesis, is that there is no dependence between these, right? They are independent. Independent, yeah, let's see. Or I should say that the number of infections is independent of the hospital. That's too much to write, so I'll just say independent. And for the alternative hypothesis, we would say the number of infections, it does not depend on what hospital you're looking at. So that is that they are dependent. And perhaps when I pause the video, I can go back and rewrite this a little bit faster. All right, the next part, we're using the traditional method or the critical value method. In other words, is we're going to go ahead and find the critical value. So it's a chi-squared test. So here's a little depiction of our chi-squared variable and the chi-squared distribution. It's always going to be a right-tailed test. So shade in the right tail of this region. It's not a great sketch, but it doesn't have to be perfect. And then we're going to look in table G to find this critical chi-squared value. So I'll say chi-squared subscript alpha, because this region has alpha equals 0.05. That's the area that's shaded in. And the reason that we're using alpha equals 0.05 is because if we look back up, it just tells us to test the claim, and it doesn't specify a value of significance level. So we're just going to use 0.05. And then the degrees of freedom for this test are going to be the number of rows minus 1 times the number of columns minus 1. So if we look back up at our contingency table, we'll see that there are 3 hospitals and 3 types of infections. So 3 rows and 3 columns. We've got 3 minus 1 times 3 minus 1. that's 2 times 2, also known as 4. Boom, got it. So flip over to table G, 4 degrees of freedom, alpha equals 0.05. We see our critical value is 9.488. So that's what we're looking at here, 9.488. Okay, then the next portion of it is to go ahead and find our test value. So this is where we write down our handy dandy formula for the test value. It's a chi-squared test. So it's going to be chi-squared. And this is the observed values minus the expected values. We square that whole difference. So O minus E, whole thing squared, divide by the expected value. And then we go ahead and do that for every entry in our contingency table, every cell in our contingency table. And then we add them all up. So it's going to be the sum of the observed value minus the expected values squared divided by each expected value. All right, so let's go to, let's see, where is it? Let's go to Google Sheets again. And here I've copied down the data. So there it is. Hospital A has 41 surgical site infections, 27 pneumonia infections, and so on and so forth. And then the only thing that was missing in the previous table, they gave us the total on the side and the total on the bottom. So we're going to use these totals. I'll go ahead and just fill them in. Here I'll type the sum of, it's helping me out. It says B3 to D3 on my screen, but that's what I'll type here, B3 to D3. And notice that that corresponds with what they had given us in the initial problem. So I'll go ahead and copy and paste that here. And then I'll do the same thing for each column. So that would be B3 to B5 there. And then we'll go ahead and copy and paste that across the bottom to give us the column totals. Okay, and one thing to notice is right here, if we look at the grand total, we're either adding up all of the row totals, that would be this whole column E, adding up all of those values, taking the total of the totals, or notice that totaling across the bottom, 246 plus 136 plus 200 does give us indeed the same thing of 582. I should move that so we can see it, 582. All right, so let's see. The next thing that we're going to do is got to find those. So those, as you can see, those are the observed values. The next thing that we have to do is calculate the expected values. So I'll write that in right there, expected values. And what I'll do is I'll actually go ahead and copy the data here. So copy and paste that right there, right below it. And of course, all of those values in the orange are the observed values. So I'll go ahead and just get rid of those. And then I'll color it in a different color, let's say green. And now, how are we going to calculate each one of these? Well, in this square that I'm at, that corresponds to Hospital A's surgical site infections. The observed value is 41. And this value, it's going to be the expected value. The way I get that is by taking the total for that whole row, 119, times the total for that whole column, So that's in the top row, the first column. So I take the total for the top row and the total for the first column and multiply them together. So it's equal to this row times this column. And then we divide that whole business by the grand total. It's just so that I don't have to keep clicking on the square every single time. I'm just going to type in 582 for each of those. All right, so what would we do if we wanted to find the value in this square, this expected value? What would that be? All right, well, yeah, as you guessed, it would be corresponding to hospital C, the pneumonia infections. So we're going to take the row total for the third row and multiply it times, well, that's in the middle column. So we'll take the column total for the middle column and then divide by 582. Okay, so I've gone ahead and done all of that. So I'm going to just delete these rows and go ahead and just keep doing that. And pretty soon, this will be right up to the top here. And we have all the expected values all filled in. All right, going back to our test statistic, what were we going to do? We were going to take the observed value, capital O, minus the expected value, capital E, that whole thing raised to the second power, so shift 6, 2, and then divided by the expected value. So that's my little formula that we're going to look at there, O minus E whole quantity squared divided by E. And the reason that I've got the orange highlighted here, these are the observed values there, and then the green highlighted here, these are the expected values. So basically for this first value here, I'll just make a little grid and fill that in with a different color. Yeah, that's pretty. Okay, so I'm going to take, for this first square, that's going to go with hospital A and the first type of horrible infection, you know, okay. We're going to say this is equal to what? I'm going to click on the observed value. Hang on one second, technical difficulties. I'm going to put a parenthesis, observed value, that square, minus the expected value. So that's the surgical site, column A for the expected value. And then close that parenthesis, raise that whole thing to the second power, and then redivide that by, I guess it's not highlighting it, so that would be divided by this one in row 11, column B, B11 again. So you can not exactly see what that is just yet until I click on it as well. There we go. So you can see there it says B3, that's this one here, minus B11, that's that one there. And then we're squaring that whole issue, you can see at the bottom, and then dividing by B11 again. Okay, so now the nice thing about this is I can copy that and paste it in, and it will repeat those calculations for each of those individual cells. So that's kind of nice. And then the last little thing that we're going to do is we're going to do the chi-squared value, which is to take all of those O minus E squared over E and add them all up. So chi-squared, I'll write it as x squared, or as best as I can do. And we'll say that's equal to the sum of all of this stuff. I'll just highlight all of that. And we get 30.696. And that might be different than what it says in the textbook, just because they rounded it and we kept the calculations going. Okay, so you got to watch that. It should be just a minor difference, 696. Okay, now the next step is what? We are going to make the decision. So in this case, where is that? 30.696 is well over in the critical region, well over here. That's where 30.696 is. So we would reject the null hypothesis. Okay, so we rejected the null hypothesis. That means that, well, let's go back up and see what we had written for H subscript 1. So we threw away this, and that means we haven't proved it, but we found strong, significant evidence in support of H subscript 1. And I didn't verbalize it before, but this time I guess I have to. So we would say, remember, we always begin talking about the evidence. We'd say there is enough evidence. There is evidence that supports our claim. And what is the claim? Is that they are dependent upon one another. So what? The number and type of infections is dependent upon the hospital where they occurred. So enough evidence to support the claim that the number of infections depends on the hospital where they occurred. And that is all there is to the chi-squared test for independence. All right, so let's go back to the share and stop recordings. Yeah, I think that did it. All right, and so that is it for our video today. Okay.